Alright, this is Quideo number 2, and we're going to do the basic question first. So the basic question is, here are Professor Moore's time in minutes to swim 2,000 yards and his pulse rate after swimming in beats per minute for 23 sessions in the pool. So there's your data. So the first question asks, verify that a linear model appropriately models the data and state the equation of the linear model. So to figure this out, what I did was I plugged it into the calculator, as you guys can see over here. Well, you can't really see it, but I plugged it in, we calculated it, and it turns out it was linear. And the linear equation is there as shown, and we also got the r and r squared value of the equation. 479.93 is the y-intercept, and the negative 9.694 is the slope, along with the x. So the next question is asking the next day time is 34.30 minutes. Predict the professor's pulse rate. His actual pulse rate was 152. How accurate was your prediction? So to do this, we just plug in 34.30 into the x, since that's our equation. We plug it in and we get 147.43. And our prediction was sort of off as expected. I mean, I didn't really expect it to be that accurate. So for question C, suppose you were told only that the pulse rate was 152. You now want to predict the swimming time. Find the equation of the least squares regression line that is appropriate for this purpose. What is your prediction and how accurate is it? So what I did was I flipped this equation from up here, and I flipped it around. So what I did was 152, since that's the time that, or that's the pulse rate that we're given, and I plugged in the rest of the equation except for x, and we solve for x. So I would subtract 479.93 to the other side, and then divide it by negative 9.694, and that gave us a pulse or time rate. Of 33.83. Also calculate the residual for it, and our residual was 4.57, which is not very good. Obviously there's some problems with doing hand calculations and calculations that can adjust this or affect this graph or data. So for D, explain clearly to someone who knows no statistics why there need to be two different regression times for parts A and C. So there need to be two different regression lines because it helps display the data more efficiently. So let's say linear is like going into like a straight line. Linear shows the trend of the data, the form, the strength, all that. Residual is used to help access or help assess how well the line describes the data. It refers to the least square regression line, or LSR. And yeah, that is it. Basic question.